So, this is my wind turbine, which shouldn't be on this drawing. And you'll notice that on this, the airfoil shape has been curved down rather than up, or like on the previous explanation for the fan. Let's make this where it's all on the screen for a change. Now you see why people don't watch my videos. I think they're informative. I say it has content, it's just not got any polish. And it's sometimes wordy. If this was a horizontal axis turbine, you had 5 blades, say, the space between those blades doesn't catch any air. Just a vertical turbine, all the air goes through the turbine. And you'll see that this is it's a wing section, except it's enhanced with the tail. So these are all positive angle of attack. And until we get to minus 20 degrees angle of attack, it's still trying to turn it this way. But whatever air these would hit is trying to slow it down. They're working against you. So the idea with the boosted turbine, first place, we want to collect all the air that goes across this turbine. We want every bit of it to go across a blade. Not 1/5 of it or 1/6 of it, but every bit. So we take, and we have a line here. These are just drawn to be sheets of plywood, and to get the angle right, I can make them any size I want. I can run them out to here, but I don't think we could slow this thing down enough. So I'm intercepting wind that width. Instead of 1/5 of this width going through the air, that much wind is going through the turbine. The air that comes through here, it doesn't affect anything. There's a tendency for air to wrap around about 7 degrees when it goes around a sharp edge, and then it goes turbulent after that. So we're getting air that'll hook this edge here and come in through here, which is right on the sweet spot to turn the turbine. But I'm not using any of that in the calculations. I can change the rake on this to make it pick up even more, but I'm not. Or I could put a bent end on it. There's a lot of things you can do to make it hit that in there, but it's just hard to explain to other people if nothing else. Anyway. Okay, now we're both looking at it. All the air that slides down this thing here, you'll notice that it's seeing about a 20-degree angle of attack. The angle between this and that's about 35, but this thing it's going to hook some. The air's going to redirect a little bit coming off that edge, about 7 degrees. So this is making lift. They're all making lift. This baffle over here, it picks up air and sends it. It just slides along that baffle. Plus any pressure here that hasn't got through the blade. Now it's going through a really good place for the angle of attack. Air out here is going to hook the edge of that and spread out in 7 degrees. It's going to catch a few of those blades. So this concept of the vanes, that's not mine. I saw that by California Edison Wind and Energy, the electrical company that powers California. They're working on basically it's a vertical axis wind turbine, and because it's so much more efficient. And they've got one big vane here and an enclosed place, and it's just a housing around here. But this one vane redirects any air that they want it to redirect, And this thing has to rotate around just on bearings, just like the tail on a horizontal axis wind turbine. They just put this big plate instead of a tail. But it's a geared motor that drives it, because the wind would try to blow it the wrong way as soon as it hit it. But they're using that to boost the air through the turbine, and they're getting about 3 times the power out of it with it as compared to without it. And there's articles on the internet, California Wind Energy. I think it's California Edison is the company, but it's the electrical co-op that powers California. It's not a government agency more than anything else. Anyway, that's what our turbine blades look like, and they were done the same way by taking an airfoil section back to where the camber line went straight, and then just changing it. And you notice that that was a mistake. You notice air that is blown through the turbine is going to hit these blades here, and that's working by the same way that your horizontal axis blades are working. It's hitting on the flat surface, just putting some pressure against it when it redirects the air. Same thing that it does on the horizontal axis. So over to about here, where we have about that much of the blade is going to see some air coming out. And then on the next blade, does nothing. So we're picking up air on half of the rotor down here. And we've blocked the air from coming through this side over here with the baffle, because this baffle is its worst case point. If this baffle was swung around to where it was about right here, then we would have the whole width of that going through the turbine. And we can also have a different number of baffles out here. The reason we have 5 is because we have a 10-sided house, and that puts it over every other post of the concrete house. I think this is the okay, this is the fan blades sliced into things an inch apart, and you can basically cut pieces and then stack them up and sand them. Not a real efficient way of doing it, but it gives you a chance to see how it's changing shape from one end to the other, if nothing else, to find out if all of it has got the angle of attack you want. You might want to flatten out the ones at the tip and put more angle on the ones in the center. But that was probably 2 years ago, and that's the blades that it came off of. This is our 6 blades. There'll be one purple blade on this side and one on that side. If we look at that, well, we can do better than that. Wait a minute. Curve from objects, put edge. There's the shape of our blade, okay? And the one on the other end, of course, would be turned the other way. The rounded end would be on that end because it's on that side. If this one went on around, it would be that one over there. This thing, it goes down in the middle, and then it's flat where it bolts to this hub up here, which is out of view. Still out of view. If we look at the actual metal parts on the floor, this would be easier. This is our hub with a welding hub and a Type E demountable bushing. Anyway, this bolts to these, and they're stacked up. So you have one that's absolutely straight across. You have one that's high in the middle and one that's low in the middle. The result is that the working edges of these blades are all in the same plane. When you have a ceiling fan in your house that shakes, it's not out of balance. I don't know why people say it's out of balance. It's not out of balance. That's not your problem. Let's see here. This might be it down here. Okay, if I put a straight edge across the tips of that wing on the end of the airfoil, and then that's for the red airfoil. If I take the blue airfoil, those are the tips, the pointy things that are sticking up at the back. Here's your airfoil curve down around here, comes up to that. If I take the blue, those tips are also all at the same height. So these blades, the actual blades, are in the same plane. So they're not robbing air from the following blade, which has to work in a lower pressure, which means that the lower pressure tries to bend the blade up. As it turns round and round, it tries to tilt your fan on your ceiling. And that's why it's wobbling. They're all on right now. If I had one off, we take masking tape and put it on the tips of the blades and number them 1 through 5. And then we put a little pencil X on the ceiling, get on a ladder, and measure from the leading edge to where it cuts the air up to that tape. And we write down what the measurements are. And we're finding 0.7 of a centimeter difference between one blade and the other on a brand new fan. So it bolts on with onto an arm that goes to the fan motor. There's 3 screws that hold the paddle blade onto that bracket. And what we do is put one washer for every 4 millimeters under the front screw until we get all up to the same plane. And then we turn them on, they don't shake anymore. So if you didn't learn anything else by getting lost on this channel, you might learn that. And now we're down there. We were over here someplace. Oh, the reason for doing this without the blades is I can chuck this onto a CNC machine. Take wood strips that are laminated across the thing. I can actually run there, put them on a CNC router, and I can cut out this horrible shape. And it won't even need sanded. It'll be right on the shape. The other thing I could do, if I didn't have a CNC router, which I don't in the Philippines, but I'm going to take this pattern on vacation when I go back home and chop them out. Because you turn it on and go away for all night. In the morning, come sweep the dust up and take your part off. There's one side and then the other side. And it's reliable enough. I can let it run for 2 days straight and then go check on it. As long as I got it bolted well to the table. I can cut it into strips. Cut the part. I can slice it with the computer, and it will make a shape. It'll have that drop center or that straight shape, and it will be, when I look at it straight on, it'll be showing me the big side because the smaller side will be hid behind it. So I'll have the biggest side, top and bottom. In other words, there won't be anything that's lacking, and I can glue those together because the center I know is going to be flat. and I know that the other end, these points are going to be right on each other. And I can glue them up, and then use the angle grinder with a sanding blade, about a 24 grit disc, and I can make that in the Philippines, no problem. The only thing I'm lacking right now is I'm gonna, on the top blade, which is the purple blade, I'm gonna add a piece to the figure over around. Yeah, talking point. I'm gonna add something from out here around over to there, because when I put this hole the size of that blue thing in the middle, it's not gonna be very strong there. It is gonna be bolted at 1, 2, 3, 4, 5 bolt holes, 6 bolt holes, which is a pretty good grip on the thing. But I'll just feel safer if the top one, which is going to have to be hollowed out for this hub, it sticks down into it, that it has more material around it. So I'm going to add that to the 3D figure, the 3D model, and then I'll run it through the G-code generator. Okay. So that's how we do them. Airfoil Tools is a site that you can get the coordinates and make your airfoils. It's also got the fairly accurate pictures. They were done by like college students as extra credit, so they were graded. If you're going to do something for a grade, you know. There's another site, University of Illinois Urbana campus, so UIUC /AE, Aeronautical Department. They got a lot of stuff on airfoils, but all you're going for is a front shape, you know, that is lowest possible drag going into the air. To extract what you want out of it. And obviously a symmetrical airfoil, you could, a symmetrical airfoil, this camber line here and this cord are the same line because it's a 0 camber. A 3 camber, this is a 2 camber, a 3 camber would be higher, a 1 camber would be lower. And they could be a 0.72 camber, and they'll still call it a 1 because that's the closest whole number. If you don't know what your camber line looks like, you can slice your airfoil in half, flip this 180 degrees, and the difference between those is the camber. Never mind. I used to consult on small airplanes. It's nothing you need to be concerned with. But you can, if you're going to do a blade that's just going to work like a flat piece of plywood, and start out with a symmetrical blade. If you're not going to change the tail at all, then the symmetrical airfoil is like a horizontal axis wind turbine, a symmetrical airfoil shape. One, it's very easy to make. You cut a pattern out, just get it printed. You cut it out full scale to what you want for the root, the end at the hub, and the end that you want at the other end of the tip. And you stick them on the ends of styrofoam and look up hot wire cutter. You can buy them, it's easier to make them. You just take this closed cell styrofoam like the Blue Builder's foam. Dow makes it. You can get it at Lowe's and Home Depot, and here we can get it up in Imus. There's 4 or 5 places that make it and sell it. It's next to Manila. But you take the foam and you just drag a wire that's heated to about 700 degrees, 15 amps probably, around, 15 volts. The amps are low. And it melts that shape out. And then you wrap fiberglass around it. And to get this pointy end in the back nice and thin, you do the top all the way back as far as you want. Generally, you put a little square block on your pattern so it's not thin there, because it'll heat and burn through. But you cut the top, and then you take your fiberglass, you put about 3 layers over it, and wrap them a little bit more, and a little bit more around the bottom, so there's not all ending in the same place. And you wrap them longer so that little fuzzy ends get held flat, no sharp things sticking up. And then you come back here and you got this fiberglass that's the right shape, and you cut out that little block of foam and hand sanded, blend it, and actually when you cut it like this, the easier way to do it is just where it's still thick, cut your foam away, glass the same thing, 3 layers, and just push them up into that and glue them to this bottom layer of fiberglass right here. So you'll have a 6-layer thick laminate out here with an open place in the bottom that's not matching your thing at all. And then you mix something like sawdust in your resin, or if you're going to a place that sells fiberglass parts, you can get micro balloons. They're just extremely small glass spheres, but they're light and they sand really well. And you just put that in there and then you sand that to the contour. If you try to cut your foam, there's nothing holding the back end together. You can't wrap fiberglass around a real sharp corner. It'll pop up, make an air pocket as soon as you walk away from it. But you can run it out here around the front and then do the bottom half, and just you can just shape that to where it'll go up and lay against this other fiberglass you've already made, and then fill in the difference. It takes about an inch space here to get enough thickness, inch from the trailing edge. And then you just cut off a straight line back here when you're done, because it'll be sloppy as a devil. You want to cut that when it's still half green. You can touch it. You can't leave fingerprints in it. You can bend it a little bit, but it's not the least bit sticky. It's sort of like rubber. They call it the rubber state. And you can put a straight edge up there and just cut it with a utility knife, drywall knife. Cuts really easy. Cuts through the glass and the resin. Gives you a really clean edge. And when you do the second, when you turn it up and you cut that on that same green edge, and then very little sanding to make an absolutely straight line. Okay. About the longest you want to hot wire is 4 feet, but that would give you an 8-foot diameter horizontal axis wind turbine, and that's as probably much as anybody's really going to make, at least in a horizontal axis. After that, you're looking for some real generator capacity. Go vertical, or put multiple blades, stages of blades. Like you'd have 5 blades, and then back I don't know, 25% of the cord. You put another set, but you rotate them to where the redirected air off this trailing edge is hitting that second blade and putting all the air on the second blade set. You have to look it up in aerodynamics. We have to worry about it because we can't put a tailplane back here that the downwash from the wing changes from running over top of it. As you tilt the nose up to make more lift, like for landings, then it runs right across your tailplane and takes the lift away. Bang! Dig a hole in the ground. So we have to be mindful of this, of the downflow. If you have a Cessna Piper Cub kind of thing, the tailplane is down, but the wing is so high it never deflects the air down to it. But if you have a low wing plane, like jet airliners, most of the time you'll see the tailplane's up high on top of the tail. That's because this air that's coming down. They have a lot of spoilers and devices back here that really send the air down. That's where most of your lift is this air. You're putting a mass of air down, and the reaction against the air that's still coming is pushing the plane up. 20% of your lift is what they taught you in high school, the Bernoulli lift. It occurs on 19 to 31% of your airfoil. The front, top and bottom, is positive pressure. The bottom is positive pressure, but it's not very effective. And this back here is negative pressure, which is more than you're getting off the bottom. So if you try to use Bernoulli lift, you're trying to generate 300 or 400 pounds to the square foot of a wing. What you really capture is the air going down, that downflow. So that you redirect the air with the wing. And you don't need none of this either. Okay? Anyway, if you're interested in wind turbines, there's an explanations of how all the ways you can wire a stator. There's about 6 ways you can wire a stator. There's one you can build a stator one time and change the way it's wired if you think you can get higher performance in one of the alternate wirings without having to build a whole new stator. Your money's tied up in magnet wire, you know, and some of it in the epoxy. But if you have, well, just look at the video. It's no use me trying to go over it here. If you want to know more about the vertical wind turbine, there's videos on that. And there's videos about concrete forms and building boats and some other stuff in here too. If you're trying to find our site, the icon near the video, like the channel icon, that'll take you to it. But typing in concrete house building in PH, we're so unpopular, not so unwatched, it won't take you there. We're not ranked in YouTube at all. I typed in the worst ranked YouTube videos, and every one of them is 75 times more popular than us. It would have been depressing if I didn't find it halfway as funny. Okay, on to other things. I'm gonna split this in two because anything you really want to know is probably in the first half. Of course, anybody that watched the second half, there's been some things in there that might be of use. Okay, have a nice day. I'm gonna turn this off.